In this chapter, we're going to talk about matrices, and in particular, how we can use them to talk about or solve systems of linear equations. So let's just start with the matrix basics. So a matrix is just a rectangular array of numbers. Okay, that's literally all it is. So it's a box with numbers in it. Now the arrangement of the numbers matters. Okay, so where a number is located in the box or the array is important. And when we are talking about a system of equations with a matrix, we usually use what we call an augmented matrix. Okay, so this is a matrix that has a line, a vertical line, that separates the columns into two sets. Okay, these two sets represent the left and right hand sides of the equations. So if we look at this system down here in example 2, there's one side of the equation and then the other side of the equation. So the equals is where the vertical line is. The numbers within the matrix are called entries, and we describe their position. So like I said, their position is important. We describe their position by which row and which column they're in. So here we're just going to represent systems of equations using augmented matrix. So here's a system of equations. So x minus y equals 5 and 2x minus 5y equals 4. So what you want to make sure when you're putting your equations into a matrix, you want to make sure the variables are lined up. And what I mean here is vertically. Okay, so notice that the x's are above each other and the y's are above each other. So I will always give them to you in the proper order, but when you make your own system, it might be that you have them reversed, so you want to be careful that they're in the same order. So when we want to put this into an augmented matrix, what we're going to have, actually I'm going to go down below here. What we're going to have is a matrix that has 2 rows and 3 columns. Okay, now row 1 is going to be for equation 1, and row 2 is going to be for equation 2. Okay, now the columns are going to be, we're going to have a variable for x, a column for x's, a column for y's, and then we're going to have our vertical line, which some people do as a dotted line. Okay, that's for the equals. And then we're going to have a column for the numbers, the constants that are on the other side. So the way that I would put this system into a matrix is you just have the coefficients. So because we know what each spot means, so this spot is the x coefficient in equation 1 because we're in row 1, column 1. This spot here is in row 1, column 2, so it's going to be the coefficient of y. Okay, so we're going to have a 1, a -1, and then a 5 is the number. And then we're going to have a 2, a -5, and then a 4 in our row 2. Now, some extra terminology here. The part of the matrix to the left of the vertical line is called the coefficient side. Okay, where the to the right of the vertical line is called the constant side or the augmented side. Okay, so that's how we turn it into a matrix. So some notes that I mentioned as I was going through that. We're going to have one row for each equation in our system. Okay, we're going to have one column before the vertical line. For each variable. So you're going to have your equations in what we call general form. So you want all your variables on the left side and all the numbers on the right side. Okay, so one column before the vertical line for each variable. Okay, one column after the vertical line for the constants in each equation. And then the vertical line is a placeholder for the equal sign. So for the equality. So that's how we're going to put them in. So I'm just going to make a note here. Okay, you need your equations in the form. So a constant times x plus a constant times y equals some other constant. Okay, so they have to be in that form. And you want your variables to be lined up. So let's just do one more example here. So this is a bigger example. So notice that we have 3 equations. And also 3 variables. Okay, so all the x's, all the y's, and all the z's. And over here are all of our numbers that don't have variables associated with them. So in a matrix, so an augmented matrix, this would look like, so we're going to have 3 rows and 3 columns before my vertical line and then 1 column after. Okay, so we're going to have an x column, a y column, a z column, and a column for the numbers. Equation 1, equation 2, and equation 3 for the rows. And then I just write the coefficients in. So in the equation 1, the coefficient of x is -1. The coefficient of y is -1, and there's no 0. So that means that it has coefficient 0. Or sorry, there's no z. So that means it has coefficient 0. And the constant is -3. In equation 2, the coefficient of x is 2. The coefficient of y is -3. The coefficient of z is +1. And the constant is always +1. Is also +1. And then in the third equation, I'm going to have a +1, and then a +5 for y, a -7 for z, and a 0 for the constant. So now I've transformed it into an augmented matrix. So throughout this first section of chapter 5, we're going to be working with these augmented matrices. So we want to be able to go from a system of linear equations to an augmented matrix, and also from an augmented matrix to a system of linear equations.